And hello, everyone, and thank you for joining us today for what I think is a really exciting topic, agentic AI for fraud detection. Now, the key idea we'll focus on today is this. Agentic AI doesn't just query graphs, it builds and operates fraud detection systems. And what we'll show is just how that works in practice using real graph operations, not static analysis. So at a high level, we'll cover three things. First, what agentic AI looks like in a fraud use case and how it connects to real systems. Second, how agents move from simply answering questions to executing real workflows. And third, how TigerGraph enables agents to build, update, and operate a fraud detection graph end to end. Then we'll bring it all together with a live demo, and we'll see how an agent can build a fraud graph, load transaction data, detect connected fraud patterns, and update the system in real time. So for the demo, we'll use Cursor as the interface for this agentic system to talk to TigerGraph through an MCP server. And we'll run everything on Savannah, which is our managed cloud service, just for simplicity. But keep in mind that everything you'll see today works in the same way for an on-prem deployment with our TigerGraph enterprise license, as well as our cloud Savannah product. All right, so let's break down what's actually happening when you use an agentic AI for fraud detection. So at the top is agentic AI. This is our decision layer. This is where the system understands what the analyst is trying to do, and it plans the investigation and it decides the next step. In the middle, we have MCP. So MCP doesn't make decisions. It simply provides a standard way for the agent to access tools like TigerGraph without custom integrations. And at the bottom is TigerGraph. This is where the work actually happens. So this is the system that builds the transaction graph, that runs the multi-hop queries, and that does the fraud detection, including fraud ranks. So each layer has a very clear role. The agent decides, MCP connects, and TigerGraph executes. And when you combine these, you move from a simple request to a system that's continuously building, updating, and operating a fraud detection graph in real time. So before we go deeper, it's important to clarify exactly what that MCP server is, because it often gets confused with agentic AI. So MCP stands for Model Context Protocol, but the simplest way to think about it is like this. It's a standard interface that connects AI to systems. So MCP doesn't make any decisions. It doesn't do any reasoning. It simply provides a consistent way for agents to access tools and data. And what it does is it standardizes how tools are called. So instead of building custom integrations for every system, agents can interact with them through a uniform way. And what that means is that there's no need to build custom APIs. There's no one-off integrations that's required. It's just a clean, secure interface between AI and enterprise systems. And so MCP is not the intelligence, it's the plumbing that makes the access possible. So what's really striking though here, and what's really different about MCP is just how fast MCP has been adopted throughout the tech industry. It was introduced by Anthropic in late 2024 to solve a real problem. AI systems were becoming very powerful, but connecting them to tools and data was still fragmented and hard to scale. And so MCP standardized that interaction, how models access context, call tools, and get results back. And that unlocked very rapid adoption. What you're seeing here in this chart is a classic bottoms-up adoption curve. It starts with developers and tools like Cursor. then quickly moves to major platforms like OpenAI and Google, and then followed by enterprise integrations with Microsoft. And ultimately, standardization under the Linux Foundation. So Anthropic actually gave the MCP IP to the Linux Foundation. And all of this happens in roughly 12 months, which is extremely fast for something at the infrastructure layer. And that's why MCP is now emerging as the control plane standard for AI agents. And historically, there's only been a handful of technologies that follow this kind of trajectory. So you think of Kubernetes or REST APIs or other examples, but this is really been a staggering adoption rate that we've seen with MCP. So to understand why MCP matters and what it actually does in the stack, we need to start with what's changing in AI. So what's driving this adoption, right? Well, that's really the story of how AI is changing. And we're moving from assistive AI to operational AI. So it's no longer just about answering questions. Agents are now expected to analyze, decide, and take action. And in this context, in the context of fraud detection, that requires access to real systems. So the data, the transactions, the identities, that's where the real value is in enterprise systems. And however, LLMs on their own can't access or operate that data, right? It's not accessible to LLMs natively. And that creates a fundamental problem. So today, integrations are fragmented and custom built. Every system requires APIs, orchestration, and a lot of manual effort and custom built. It's slow, it's complex, and it doesn't scale. And that's what MCP solves. MCP provides a standard interface to expose systems as tools that agents can use. So instead of building integrations over and over again, you expose capabilities once. And that allows agents to discover tools, what tools are available to them, interact with systems, and execute workflows. And so the key shift is really this move from reasoning to execution. So let's look at how all of these pieces come together in a real system. So starting on the left, everything begins with a user request or event. So for example, investigating suspicious transactions. Now, the reasoning model is the first step. This is where the system breaks down the problem, it figures out what needs to be done, and it generates a plan. Now, what's the agentic part of this is that this system doesn't follow a prescribed workflow. It actually comes up with this plan independently through the interaction with the LLM. And so then this plan is handed to the agent, which is then responsible for execution. And the agent orchestrates the workflow. It selects the right tools, it sequences the steps, and it manages the process end to end. And we'll see that in the demo as well. And MCP sits in the middle as the connection layer. It provides a standard way for the agent to access tools and systems without custom integrations. And so on the right-hand side is where the actual work happens. You have enterprise systems and data. And this is where data is accessed, graphs are built, queries are run, and fraud is detected. So instead of a static workflow, you now have a system that is dynamically planning and executing in real time. All right, so this is where TigerGraph really differentiates in the MCP ecosystem. Because most MCP integrations expose just a few APIs, typically just for querying data. What TigerGraph does, it exposes the entire graph lifecycle as MCP tools. So currently we're offering 65 tools, and that number continues to increase over time. And what that means is that an agent isn't limited to reading data. It can actually operate the graph end to end. So if you look across these systems, they map directly to what's needed for fraud detection. You have graph management, where you can create and involve the fraud graph. You have nodes and edge operations, where you can continuously update entities and relationships. You have query operations, where you can run multiple analysis to detect connected fraud patterns. You have data loading that brings in new transaction in real time. You have vector operations that enables similarity and hybrid AI use cases. You have workflow and discovery that allows agents to find and execute the right actions. So instead of stitching together these multiple systems, everything is available through a single consistent interface. And the key point is this. The agent is not just querying the graph. It's building it, updating it, and using it to detect fraud continuously. All right, so up to this point, we've talked about what agents can do. But what is just as important is what they're allowed to do. So when you give agents the ability to operate systems, control becomes critical, especially in something like fraud detection and in an enterprise environment. So the real challenge is, how do you safely expose that level of power? And that's where the enterprise guardrails come in. So first, RBAC is enforced at the database level. So access is tied to a user identity. So agents can only perform actions that the user is authorized to take. Second, security is inherited. It's not recreated. So there's no permission, there's no new permission model. MCP leverages the existing API level controls. And third, there's a clear separation of control. The model can call the tools. The agent governs which tools are available, and TigerGraph enforces what is actually allowed. So even though agents can operate the fraud graph end to end, they always operate within the enterprise defined boundaries. All right, now let's bring it all together and see it in action. This is really the exciting part of the demo. So what we'll do is, in the demo, is that you'll see an agent go beyond analysis and actually operate the fraud detection system. Specifically, the agent will build the fraud graph, will load transaction data, and will run multiple analysis to detect fraud patterns. And then you'll also see how the graph is updated in real time. And it's going all of this is going to go through MCP, interacting with TigerGraph as the set of tools. And again, this is the key shift, where we're talking that where we're moving from just asking questions to executing workflows. Okay. All right, so let's switch over to our application. Go. Let me just switch. All right, so this is our cursor application. Again, we're using cursor as an interface, but there's many other that you can use. As you can see, I have my TigerGraph MCP server that's installed. And what I'm going to do first is I'm going to ask, the Agentic system whether it can connect to MCP. So what will happen there is it'll try to first understand the request. It'll come up with a plan. It'll ask me to confirm the query to run or the connection. And then it'll give me the response, which is that it's connected to a specific host. that it's my username, that I'm using a JWT token to authenticate, and that I'm connected to a cloud system. What I'm going to do now is show you the Savannah instance that it connects to, so that you can actually see the instance before we start running all of these agentic capabilities. So this is our Savannah instance. I'm going to go to my design schema. Here's in my MCP fraud instance. I look at the list of schema. There's no schema. I'm going to my queries. I don't have any. So this is my query editor. I don't have any queries installed. So I have essentially a blank workspace. I have no schema. I have no graph and no data. All right. So now going back to cursor. All right, so I'm gonna start by saying I'm gonna essentially create a graph. So I'm gonna use a prompt to do that, just natural language. Create a new graph called transaction fraud using MCP, and I'm gonna instruct it to use a schema using a mapping table for edges and nodes with a tabular transaction fraud file. So I've created my fraud schema mapping here. That is my fraud schema mapping, and I've got my fraud data right here. So essentially, I've given the instruction to create a graph to create the schema and then load the data. So I'm going to run it, and again, it's coming up with a plan. First, it's understanding the prompt. It's coming up with a plan. What's really nice about this is that you can actually see the reasoning of the system. So you'll see that cursor here will come up with the reasoning. It wants me to confirm some of its actions. So it's running a GSQL query. So it's going to convert those prompts into a GSQL query. It has access to the Savannah instance, so it understands the schema that needs to be created, and it can load the data, create a loading job by generating the GSQL query, and then doing that automatically. So now it's creating the loading job. I'm going to run it. Planning its next move. Loading the CSV files. Again, you can see the reasoning, which is really, really great. You don't just have a wheel spinning. It actually tells you what it's doing, and if it encounters a problem, it'll tell you that as well. So it is running the loading job. And while it does that, because it's going to take a little bit of time, I wanted to show you the actual setup of that MCP server, just to show you how easy it is. So I'm going to switch over to back to slide. Give me a minute. Okay. And this is actually how the MCP configuration looks like. So what this is the key point here is that it's a simple configuration file, right? At the high level, I'm essentially doing four things. I'm defining the TigerGraph as an MCP server. I'm specifying how to connect to it. So I'm providing a host, ports, and whether it's a cloud or on-prem instance of TigerGraph. I'm specifying also how to authenticate to it. So I'm using my username. I have a secret and a token. And I'm also specifying which LLM model to use within MCP. So note that the LLM in MCP is different from the model used in the Cursor application. And we'll go into that in the next slide. But the important takeaway here isn't the syntax, it's what it replaces. So there's no custom integration code, there's no API wiring, there's no orchestration layer to build here. You're simply exposing TigerGraph as a set of tools and that the agent can immediately start using. So about the LLM model, wanted to show you that there's actually two layers for the LLM model that's used in this agentic system. So the primary model is Claude. It's Optus 4.6, which is what we use in Cursor. And that's actually capable of doing everything on its own. It understands the schema, it interprets the requests, it generates the GSQL queries directly. So it does not depend on MCP to generate queries. But we do have a second layer, which is optional. This is enabling LLM through MCP, where we expose a GSQL query generation capability that can be used when needed. For example, if you want more control or standardized way to generate queries. So again, there's no dependency here. This is more of a flexibility. You can rely entirely on the primary model, which is essentially what we're doing in this demo. But you can also leverage NCP-based tools as needed with that secondary LLM access. All right, now let's go back to see what our Cursor application has been up to. All right, so it's loaded the data. As you can see, it has validated that there were 71,000 lines. And here it's giving me the analysis of the data that was loaded. So there's 26,000 payment transactions, 171 merchants. It counted the edge as well as the nodes and gave me a summary here. So what we're going to do now is let's quickly look at the actual Savannah instance. So we can see what we can see if the graph actually shows up in Savannah. So I'm going to go to there it is. So this is the schema that was created. As you can see, that it's the transaction fraud schema. So this is exactly what we just created. If I look at my data profile, I'm going to go back to my workspace, go to data profile. And here's number of vertices, number of edges, and you can see that it's got 71,000 payment transactions, and then more data there. So you see that it actually loaded every component there. All right, so let's go back to Cursor, and what we're going to do now is we're going to now that we've loaded the data, we're going to run a couple queries. So let me just go ahead and pick that up. I have a prompt ready. So I want to create and install a query that shows the total fraud transaction count and the total fraud amount by city and state. So again, it's going to interpret the query. It's going to come up with a plan. It's going to construct the GSQL query, and it's going to run it and return the results to the user. So it's going to confirm. So you see here, it actually created the GSQL query, and you can see that it's pretty extensive. And the key thing here is that it came up with the query parameters based on its understanding and knowledge of the schema. Right? I didn't have to write anything. I just had to essentially have a natural language to explain what I wanted it to do. And it actually came up with a fairly complex query that includes accumulators. It uses the right parameters. And then it'll also install the query. So I'm going to go ahead and run that. It's going to take a bit of time to just again, it already created the query. You have to install it and then run it. But you see the reasoning in real time, right? So it'll actually list out what it's doing. You can stop these actions at any time. So you do have a stop button here if you want to cancel it. But we'll let it run its course. All right, here it is. It's created the query and installed it. It's going to run it. It's asking for permission. I'm going to go ahead and give it. All right, and now it's giving me the result. So it's again, I've asked for fraud by city and state, so it's giving me the list of states. It also is providing the total fraud amount, so it actually followed the instructions to the letter. And then it's giving me the cities first, and then the state. And what's really nice about this is that first it returns the data accurately, so it understands the query, returns the results accurately, but it also interprets it, right? So it tells you California leads with 82 fraud transaction totaling, $51,000. Again, you can ask it more detail, just like you would in ChatGPT or in other LLMs. But it interprets the data, so it's actually a nice addition to just not just rendering the data, not just returning the data. So let's try another query. So here we're gonna find the top 10 merchants with the highest fraud count. Again, it's going to understand the intent, convert that. It's going to call it's going to convert that into a query. Then it's going to call the MCP server to execute those queries and then return the results and interpret it. And while it does that, let's actually go to Savannah to see the query that was actually installed. So you go ahead and switch screens. All right, so here's our fraud detection. Again, I'm going to go to query editor. Now I do see queries. I see my schema here, and I can see that the two queries that were created and installed. So it actually interacts with Savannah. I can actually look at the query as well here, and I can modify it, but it's exactly the same that was created. This is the other query that was created, and I can run these queries in Savannah. But again, it's easier to just use Cursor and do that directly using the natural language. So it's asking me to run it. All right, so here's the data. So again, it interprets it. It says all top 10 merchants have 7 transactions each, ranked by total fraud amount. And again, it returns the right data and interprets it. We're going to run one more query. We'll look at fraud rings, see if there's any. So we're going to ask it to create and install a query that detects fraud rings. We want to look at those transactions where the party shares the same device or IP address, if there's any. Again, it's confirming the graph to use in the command, and you can actually see again the GSQL query, which is pretty sophisticated. Again, we're going to go ahead and run it. It's going to take some time again to install the query and run it. And it's doing all this through the MCP server, calling the tools that TigerGraph exposes. So right now it's running the GSQL in TigerGraph, taking a bit of time. And it's okay, so the query was installed. Let's run it. So installing the query took the longest time here in the process. So the fraud detection fraud rings have been created and installed. The total fraud party is 74. There was no shared IP address and no shared device in this case. So again, it explains the results in natural language. And some of the other operations you can do here is you can also ask it, for instance, to list all the users who have access to the graph. So you can actually have user operations as well. So it's going to show this is not a query, it's just a command. So show user command. Again, it understood the request. And it came up with all the users that have access to the graph. And what I'm going to do now is I'm going to delete the graph. So if you think of if you're let's say if you're a developer and you're doing some prototyping on your graph, and you want to just really quickly launch a graph using natural language, you have some data that you want to test. You can do this very easily, as you've seen. But what we're going to do now is we're going to delete the graph, and let's say we want to start over. And again, what we're showing here is how easy it is to operate that graph using natural language. So I'm going to go back to my graph. Here it is. If I look at my queries now, I have my 4 queries. My schema is here. So again, everything is being set up through the agentic system. Actually, I didn't show you that. Let me make sure I show you the right screen. All right, so here it is. I've got my 3 queries identified that's been installed. I've got my graph schema. And what I'm going to do now is I'm going to go ahead and delete the graph. So I'm going to say MCP. You don't have to say using MCP. I think it's able to do that. It's able to understand that, but you can have a more you can define your prompt. It wants to confirm the graph name to be deleted. It's going to again, it's going to delete the global schema. So it understands everything that needs to be done in order to complete this task in full. So 3 queries were dropped. 1 loading job was dropped. The transaction fraud graph was dropped, and the global schema was dropped. So again, it summarizes what it did. And as you can see, it's extremely powerful, right? You can create a graph. You can also delete a graph. You can run queries. And so really the key here, it's really important, is the ability to control to have controls in place so that you only users with the right permissions are able to execute those commands. All right, so let's go back to our presentation. All right. So really to wrap this up, what we want to reinforce here today is that the key idea we've been building through this session is that agentic AI can take action. But what really makes TigerGraph different is just how much of the system those agents can actually operate. And you saw that in the demo. Within 15, 20 minutes, we were able to create a graph, load data, run queries, and then delete that graph as well. So TigerGraph exposes over 65 tools that's giving agents broad access to real system execution, not just querying data. And because of that, agents are able to operate the full graph lifecycle end to end, as we've seen. So the best way to understand this is to really try it yourself. So you can get started with TigerGraph Savannah very easily and for free at tgcloud.io. Just scan the QR code here and launch your own environment in minutes. And if you want to go deeper, and you can actually download and run TigerGraph's MCP server directly from our GitHub repo and start building your own agentic workflow. So we've put the link here for the GitHub repo. It's an open repo. Our MCP server is open source, so you can download it and use it and even update it and modify it if you want. And the same setup will work with chat interfaces, agent frameworks like LangGraph, or even embedded directly in your enterprise system. So again, we've used Cursor in this demo, but that's just one interface. And it's a great developer tool, but you can use many others that will operate exactly the same way. The interface may change, but the underlying system stays the same.